Torsten, this has been a very intense supercomputing for you. You have a lot of contributions, and now you also have a lot of your group here. So I would like you to walk with me and describe me what is the contribution of the students to this supercomputing and to your work in general, I mean at ETH Zurich.
So yes, I have a very large group here, and in fact this is just a subsample of the group that we could find that is now celebrating the big success. So let us just go around and talk a bit to the people that we have here. So the first one I would say is Marcin, who is the big winner of the gold medal of the ACM student research competition today. So, so Marcin, how did you get the medal?
I won the competition. So I first had to submit a poster, which was selected out of many candidates. I presented the poster to judges on Tuesday poster reception. Afterwards, they selected 5 best finalists who gave circa 8-minute talk on Wednesday, and out of that, they selected the best ones.
And obviously, you were the best one. So at least in the committee's view. So there's just to continue this, there's another student here who's a superstar. So Greg, who's one of the authors, or actually the lead author of the best student paper at supercomputing. So how did you get that paper?
Well, it was quite a lot of work because it combines both theory and practice. So together with Marco, the person that implemented it, we put really a lot of effort to prove that in practice we are really fast, and actually that was a pretty surprising result, that in a classical old algorithm which is matrix multiplication, you can still show something and outperform best vendors here.
Okay, great. Then enjoy your night at the table, and we move to the next one.
So let's move on, and yes, I think the best thing is that you introduce your own students, because for me it would be not so easy.
So let me start here with one who has been named multiple times as my student here at the conference. However, he is not my student. He is in fact a postdoc at the University of Pisa, a close collaborator from Italy who has been visiting last year, and together we have been working on a paper that was highly successful. So can you tell us like 1-2 sentences about this?
Yeah, sure. So what we did is that we improved the routing strategies on some networks which are commonly used in supercomputers, and so we were able to improve application performances up to 2 times by tuning the way in which the routing works on these kind of networks.
Now I have a different question for you. So how is to collaborate with Torsten?
Actually, it was really nice. I mean, we had a very successful collaboration, and I mean, for me was a really good opportunity to also to see something else, because I mean that was not probably my research area, so I just started working on it, and now I think I will continue working on that kind of stuff.
Very good. Thank you.
So the next one in the Italian corner here is Tiziano, who is actually my proper postdoc. So what are you working on?
I'm working on FPGAs for high-performance computing, and in this conference I've presented this paper about distributed memory programming for cluster of FPGAs. So the idea was to essentially combine both message passing and hardware programming in order to achieve a nice programming model for this kind of devices.
Okay, should we move on?
Sure. So Torsten, you receive a lot of requests also from vendors and people selling hardware here at supercomputing. So how do you deal with all these people that want you to test? We talked about the FPGA. Do you say yes to everything, or you have some more critical approach?
I don't say yes to everything. In fact, I'm extremely selective. But one of the companies that we are working with is, for example, Cray, because it's why would you not work with Cray? And that gets us to the next person in line here, part of the Italian part. So Salvatore, so tell us about what you're working on.
Yeah, so this is a continuation of our work that we presented at SC19, and is about a network offloading. So, and the research question was how do we exploit now this technology for real application? And this is why we used Spin to accelerate MPI data types.
Excellent. So we hope to see this in some future supercomputer products, and I'm actually pretty sure this will happen. Then we have Maciej at the table, who has been one of the finalists for Best Paper and Best Student Paper in the group. So Maciej, what are you working on?
So our paper was on slim graph, which is really the first thematic approach for lossy graph compression and approximate graph computations, analytics, and storage.
Very good. So, Torsten, now I ask you another question. So, are you attracting all the best students, or are you looking for all the best students at ETH and worldwide?
I have no idea. In fact, my students come from a very broad spectrum of different countries, continents, and parts of the world. So, for example, here, all 3 different nationalities on the table. So, so this is how it goes. So let me join you here. What was your success today? And where are you from?
I'm from Greece. So my success was the Gordon Bell Award. And we were able to use a data-centric framework to optimize a domain science application that was also been developed in ETH from Professor Matthew Lizier. And yeah, we are very happy about it. So
the next one, where are you from and what have you done here at the conference?
Yes, so I'm Tal, I'm from Israel. Most of the work that we show in the Gordon Bell Award is actually powered by data-centric parallel programming, which is a workflow and paradigm that we've been developing at ETH for quite a while. What we presented in this conference as well is the intermediate representation that is the engine behind it all. Essentially a graph-based representation that can be compiled directly from Python into CPUs, GPUs, FPGAs, and can be transformed separately so that domain scientists can keep working on their application in a high level where it can be optimized completely separately.
Oh, great. And then to the last one at the table, last but not least, definitely. So, Johannes, where are you from and what are you working on?
So, I'm from Denmark, up in the cold north. I'm part of the data-centric team, so I'm a core developer on the DACE project. And I am the resident FPGA PhD student, so the whole FPGA backend has been my prime responsibility. We're very interested in programmability of FPGAs, so the data-centric framework is great for that. And we also gave a tutorial at the beginning of the week to teach people on how to program FPGAs. Yep.
So, Torsten, this has been, again, as I conclude like I started, a very successful supercomputing for your group, for yourself. And so now, are you going to double the effort for supercomputing 2020?
Well, if you give me the resources, mostly the personnel resources, certainly we're going to double the effort, but we will see. And thank you for your support in general, CSCS, of the gracious support of compute resources that we always get, and also the support for the Cluster Challenge team that couldn't be here. They're already drinking in some other in some other context, so we will be going very soon.
So that's a message for us. Thank you very much for all of you for your time, and enjoy the rest of the evening and tomorrow and the rest of the weekend. Thank you.